Hey everyone, and welcome back to PNG Homeschool Tutorials. We will start on activity 9.2 in chapter 9, and that is under the subtopic area of circles. So if you are a returning viewer, welcome back. If you are new, welcome. So just a quick outline for this video. We will run through question number 1, 2, 3, and 4. So yeah, watch closely as we run through solving the problems, and feel free to comment your thoughts. If you have any other questions, please punch it into the comments, let us know, and we will get back to you. Okay, question number 1 is straightforward. All we do is plug and play. We get the radius, we substitute into the formula, and we work out the area. So for A, the area would be 12.56 square centimeters, and B, the area would be 28.26 centimeters squared, and C will be 78.5 square centimeter. Question number 2 is also straightforward. Given in the diagrams are the diameters. So all we do is divide that by 2 to get the radius, and then we substitute into the formula to work out the area. So for A, the area would be 3.14 square centimeters. And for B, the area would be 12.56 square centimeters. And then C, the area would be 7.065 square centimeters. Okay, question number 3 is about concentric circles. Now the term concentric or concentricity is referring to having the same center, okay, or coming from the same midpoint. So you see these two circles are drawn concentrically, one inside the other. Now, if we look at it that way, the shaded area is like a ring around the center of these two circles. So if you want to work out the area of the shaded region, all we do is find the area of the bigger circle, then we find the area of the smaller circle, and then we subtract the area of the smaller circle from the bigger circle. And that should give us the area of the region where it's shaded. Okay, now if we work out the area of the small circle, we get around 50.24 square meters. And if you work out the area for the larger circle, we get around 113.04 square meters. Now, we subtract the area of the smaller circle from the area of the large circle to get the area of the shaded region. And that will be around 62.8 square meters. Alright, question 4 is where we get tested on our knowledge on the concepts of circles. So it's a question for part A. We have a circle embedded in a square. Now, if we have a circle embedded in a square, that means the circle's circumference touches the sides of the square at all 4 sides, and that's in the middle. And that will tell us that the sides of the square is basically the diameter of the circle, yeah? Because you can literally draw a horizontal line across the square, and that will cut the circle as well in half, right on the diameter. Or if you do it vertically too, it will split the square into 2 as well as the circle itself. So the side of the square is basically the diameter of the circle. Now, the diameter given is 10 centimeter. We divide this one by 2 to get a radius, and that will be 5 centimeter. So we use that radius in the formula to calculate the area. So remember, we are trying to calculate the area of the shaded region. So in this case, we'll calculate the area of the square, we'll calculate the area of the circle, then we subtract the area of the circle from the area of the square. And that will be the area of the shaded region. Now, when we evaluate the area of the square, we get 100 square centimeters. And when we evaluate the area of the circle with a radius 5 centimeter, we get around 78.5 square centimeters. So we now subtract the area of the circle from the area of the square to get the shaded region. And that will be 21.5 square centimeters. Question for part B. We have 2 semicircles embedded in a square. So a semicircle is half of a circle. So looking at how they are placed, we will go ahead and label them as semicircle A and B, just to give us an indication of where we are at with our calculation as we go through. Now looking at how semicircle A and semicircle B are positioned inside the square, their diameters are basically the sides of the square. And given that the bottom side is 8 centimeter, that would mean the diameter of A and B would be 8 centimeters as well. So we can now put a point in the middle as a midpoint. And from that midpoint to the edge of the square, it will be half of 8 centimeters, which is 4 centimeters. Now, we already know that 8 centimeter is the diameter of the semicircles, so that means that 4 centimeter would be the radius now, because it's from the center of the semicircle towards the edge. Okay, here's the very important part. Follow me very closely. So, if you take these two semicircles, flip them over and join them, you will get a circle. You follow me? Now let me say this again. If you take these two semicircles A and B, flip them over and join them together, they will now form a one full circle with a diameter of 8 centimeters. That should be straightforward. Okay, that's based on our understanding of circles and the square. And one more thing we need to understand with these two semicircles is, since they are half a circle, their areas are basically the same, okay? So it's like you split one circle into two and you get two semicircles. So that means area A will be just the same as area B. Okay. Now with that being said, we'll go ahead and put that into a drawing. So now you see, if you flip them over and join them, they now form this circle with a diameter of 8 centimeters. So that's it. Now you have a circle which you can work out the area easy because you already have the radius, which is 4 centimeters. And then you can subtract that area from the area of the square. Remember, you still have to calculate the area of the square and then subtract the circle from it. Now if we go ahead and evaluate the area of that circle, we should get 50.24 square centimeters. That will be the area for that circle. And if we evaluate the area of the square, that will be 8 by 8, so that's 64 square centimeters. And now we subtract the area of the circle from the square. And we get 13.76 square centimeters. And that's it. The 13.76 square centimeters is the area of the shaded region, okay? Alright, question number 4, part C. We have 4 circles all stacked up closely to each other. All of these circles are identical with a diameter of 5 centimeters given. We're gonna run through this one a bit quicker with the assumption that we now already have enough knowledge and understanding on the concept of circles and square. So we're gonna begin with the midpoint of the circle or the center point of the circles. So we place dots. Now we connect these dots from all center points. After we connect all of these dots, we now ended up with a square drawn by joining the center of all of the circles, okay? And that square captures the shaded region that we are going to calculate the area of. Now let's translate this one into another diagram so we can clearly put our dimensions down. So we're going to draw a square and we're going to draw those parts of the circles that we cut out. And now we're going to label them as A, B, C, and D, just to give us a good understanding. Now, for this new diagram that we just drawn, if you look at it closely, we now have 4/4 of a circle embedded in a square. Can you see that? And those quarters are the one that we cut out from the original drawing. If you have 4/4 of a circle, you join them all up together, you get a complete circle. Okay, I'm going to say this again. If you have 4/4 of a circle and you join them all up together, you will get a complete circle, or one full circle. We now have an area of a full circle embedded inside this square. And the radius of the circle is already given. We worked it out up there. Now let's deal with this square. So the radius that we have up there, we know that from the edge of the square to the middle, it will be 2.5 centimeter. And from the middle to the edge, it will be another 2.5 centimeter. We now have a square of side 5 centimeter. Okay, so like we've been doing, we work out the area of the circle, we work out the area of the square, and then we subtract the area of the circle from the square to get the area of the shaded region. So we evaluate the area of the square. That will be 5 centimeter by 5 centimeter, and that's 25 square centimeters. And we go ahead and evaluate the area of that imaginary circle. We can denote the area of the circle as the quarter A plus quarter B plus quarter C plus quarter D. And if we plug the values to the formula, we'll get around 19.625 square centimeters. Now we can move on to work out the area of the shaded part. That means we subtract the area of the circle from the area of the square. And that will be 5.375 square centimeters. And that's it. There you go. If you're still having doubts or confusion, please put it in the comments below. Let us have a look at it and get back to you. And if you have watched this far, thank you. Please don't forget to hit the subscribe and like button. And also please share the video to your classmates who you think is gonna need it. Thank you and bye bye.